You try this one. What mass of carbon dioxide could you make if 4 grams of propane is allowed to react with an excess of oxygen? If you stop and think about it, by the way, what kind of reaction is that? Of the 5 types of chemical reactions, which one is that? Anybody?
Single replacement?
Nope,
Or
not double replacement. It's
combustion?
combustion. It's combustion, yeah. So it's a hydrocarbon, presents oxygen, making carbon dioxide and water, right? So there's some good review. Make sure you look over those 5 types of chemical reactions again. But let's say we got this combustion reaction. Think about it. Most of the time when you burn something, the oxygen is in excess. Usually the fuel runs out before the oxygen in the room runs out, right? So combustion reactions are almost always excess problems, if you think about it, right? So this is like a real world problem. Say you burn 4 grams of propane, okay, in an excess of oxygen, which is generally the case. I want to know how many grams of CO2 could you make? Give this a shot. You got this. Excess, most beautiful word in the English language. You're going to find out why here in about 5 minutes. All right, folks, let's do it. We jumping from here to here. First thing we got to do, we got to divide by that molar mass of propane, 44.11 grams of C3H8 per mole of C3H8. And then it's time to jump is going to be 1 mole of C3H8 to 3 moles of CO2. And then moles of CO2 to grams of CO2. 44.01 grams of CO2. 4 divided by 44.11 times 3 times 44.01. With 3 sig figs, I got 11.97. I'm rounding that to 12.0 grams of carbon dioxide, folks. You make it 12 grams of carbon dioxide. That is our theoretical yield. Our theoretical yield. Okay, let me add an extension to it because, again, we'll wrap up last stuff that's on the test. We could do a percent yield thing here, too. What if I told you that only 9.15 grams of CO2 was recovered? Based on that, go ahead and give me a percent yield, please. If only 9.15 grams of CO2 was recovered or obtained, give me a percent yield. All right, should be pretty easy. Percent yield is actual yield, 9.15 grams divided by theoretical yield, 12.0 grams times 100. So 9.15 divided by 12 times 100. That is a 76.3 or 76.25% yield on that guy. That's pretty terrible for a combustion reaction. But how we feeling, folks? That stuff is like that stuff, everything we just did there, fair game, right? Fair game for tomorrow. What's not fair game for tomorrow, though, is the next step, which is limiting reactants, folks. Let's take a look at this. Back to the bicycles, right? Of course, we got a balanced chemical reaction here. 1 frame, 2 wheels, making 1 bike. Awesome. This problem is different than what we did yesterday. Yesterday, I don't remember what part. I think I said you had 14 wheels and we had an excess of frames or something. But yesterday, I told you one of the reactants was in excess. And that made the problem really easy because you just like had to take the only thing you had a number for over to the product side. But now those days are over. I am not going to come out and tell you what reactant is in excess. Not going to do it. You're going to have to figure that out for yourself. Okay. And this would be like an example of it. Now, y'all are smart. So you could probably say, hey, if I got 8 frames and 22 wheels, I can make 8 bikes, right? Think about that. You can probably figure that out without doing any math, right? You just use some logic and the fact that you can like picture this. Problem is when we get to chemistry, you can't picture it because it's like atoms and moles and grams and stuff and it don't work. Okay. But with this, you can picture it. Now, hopefully everybody was able to figure out, oh, yeah, I'd be able to make 8 bikes. But what I'm interested in is how did you figure that out? There's a couple ways you can figure that out. But the way that is applicable or transfers over best to chemistry is this. What a lot of people do, maybe you didn't do this, but what a lot of people do is they say, 8 frames. How many bikes would that let me make? And they figure that out. And then they say 22 wheels. Huh. How many bikes would that let me make? Well, I can only make the smaller number. And that's actually exactly what we do in chemistry. Okay? Eliminating reactant problems, generally, what we do is we take the initial amount of each reactant to at least a mole, gram, molecule, whatever. We go to the same product, and the one that lets you make the least, that's going to be your theoretical yield. The reactant that lets you make the smaller number, that's going to be the one that runs out. That's the limiting reactant. And the reactant that would have let you make more, that's the one that's going to be in excess. So let me show you how we would do this doing chemistry. We would do 2 problems, and that's why limiting reactant problems are harder than excess problems. Excess problems are one problem in just one problem. A limiting reactant problem is 2 problems in one. So what you need to do, and again, we use dimensional analysis to do all of our math. We're going to take 8 frames. We're going to put that over 1. We're going to say 1 frame makes 1 bike. That's a 1-to-1 ratio. We could make 8 bikes with those 8 frames. And then we could do, we take the 22 wheels over 1. We need 2 wheels for every 1 bike. 22 wheels would let us make 11 bikes. So if I have enough frames to make 8 bikes, and I got enough wheels to make 11 bikes, how many bikes can I make? The answer, 8. That is your theoretical yield. The theoretical yield is always the smaller number. You're only allowed to make the smaller number. Okay, what else do we know? Well, we know the frames are what's going to run out, because the frames control the amount of product I can make. So what do we call the frames? In this scenario, we call the frames the limiting reactant. That's limiting reactant. And the wheels, we could have kept going. The wheels would have let me make more bikes. So what we have just determined is that the wheels are in excess. Now, before this problem, I just told you if the reactant was in excess. You got to figure it out for yourself now. Do you get the logic behind what we're about to do? We're just going to do the chemistry analog of this. If you understand this, you can understand the chemistry. Okay, and everybody can understand this, so everybody can understand the chemistry, right? We are now starting with an amount of more than 1 reactant. And the best way to do this in chemistry is to take both reactants to the same product and figure out which one's going to let you make less. That one's your limiting reactant, and the smaller number is your theoretical yield. We are going to add an extension to this problem, which is how much of the excess reactant is left over. But let's not get ahead of ourselves. Let's try this out. Blah, blah, blah. Back to this problem right here. Here's what we're going to do. Now, I am not telling you what is in excess. So we got the same problem from before, but now instead of coming out and telling you the oxygen's in excess, I'm going to say we only got 5 grams of that oxygen. So give me a second here. Let me write this back up here. Here's how this problem is different now, folks. Instead of me telling you which one of these reactants is in excess, now I'm saying, hey, man, you're mixing 4 grams of propane with 5 grams of oxygen. You don't know which one's in excess. You don't know which one's going to run out. You don't know which one, controls the amount of product we can make. When you get a problem like this, okay, you can take either one of these, you can take both of these reactants to either product. It technically would not matter which product you go to. I could take both of these to CO2 and compare. I could take both of these to H2O and compare. Okay, now usually it pays to look ahead. So in a minute, I'm going to ask something about CO2. So we may as well go to CO2. Now, what do you have to go to? Well, the answer is you could stop at moles. The fastest way would be to take both of these to moles. But if the next problem asks about grams, you may as well just go to grams. That's fine too. So here's what I want you to do. Why don't we all go to grams? Technically, you go to molecules as well and compare, right? I want you to take both of these. I want you to take this guy to grams of CO2, And I want you to take this guy to grams of CO2. And then I want you to look at the answers. And I want you to see, which one of these is going to run out? Which one's a limiting reactant? Which one of these do I have more than enough of? And which one of your answers is the theoretical yield of CO2? So there's really now two problems in one. I'm going to give you a head start. Okay, it's really nothing different. It's just longer now. You're taking this to here. We just did that. Do it again. You're taking this to here, and then we're going to compare instead of me just coming out and telling you what's in excess. Go ahead. All right. Hopefully you did that, right? We already did this one. It's good to do it again, right? The more you do it, the better you get. The 4 grams of propane would allow us to make 12 grams of the product CO2. The 5 grams of O2 allow us to only make 4.13 grams of CO2. So now we can answer some questions. The first question is, what is our theoretical yield of CO2? Well, the theoretical yield is always going to be the smaller number. So this is my theoretical yield. How many people got that for theoretical yield? Give me a thumbs up, right? Thumbs down, thumbs sideways. Oh, there's some thumbs up. That's excellent, right? Hopefully that made sense to you, right? The smaller number is the amount that you get to make, okay? Now, 2 other questions. I want to know what is the limiting reactant and which reactant is in excess. So go ahead. Can you label the limiting reactant and the excess reactant? Which reactant limits? Which reactant do you have more than enough of? So the O2 is my limiting reactant. Why? That's the one that lets me make less product. This, the O2, is going to run out way before the C3H8. The C3H8 would have let me make way more product, almost 3 times as much product. So the C3H8 is in excess. If I burn 4 grams of propane in the presence of 5 grams of oxygen, there's going to be some propane left over because it is not all going to get consumed. We're actually going to be able to calculate how much of it's left over here in a second. But how we feeling? How we feeling about this kind of problem? I don't want to tack at how much of the excess reactants left is left on yet. We'll do that in a second here. Feeling okay. All right, let's do another one. Let's do another one. Click through here, blah, 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 blah. Blah, blah, blah. Blah, blah, blah. We already did percent yield. Let's do this guy. Good review. What kind of reaction is this? Just look at that reaction. What kind of reaction is this? Out of the 5 types, what do we got here? compound, other compound, other compound. Ooh, something in the chat. Double replacement. That's right, Elliot. Very good. Thank you. Yeah, double replacement reaction, right? Silver now with chloride, calcium with nitrate. We're going to talk a lot about double replacement reactions tonight. We get into precipitation reactions and the solubility rules. But anyway, let's not get ahead of ourselves. Here's what I want to know. I want to know what the percent yield for this reaction is if only 5.5 grams of the precipitate is formed. Precipitate, fancy word for solid. So I'm giving you the actual yield of the solid. We're going to save that when 8 grams of silver nitrate is allowed to react with 3 grams of calcium chloride. I give you the actual yield of the solid. In order to get the percent yield, we need the theoretical yield. So what are you doing in this problem? Well, this is a limiting reactant problem, folks. You're going to take this guy over to here, and you're going to take this guy over to here, and you're going to get me a theoretical yield for silver chloride. And then once you have the theoretical yield, you can use the actual yield to get a percent yield. So have fun. You got this. All right. Hopefully you guys got this far. It's always hard for me to gauge time, when I'm not sitting in the same room as you. So the 8 grams of silver nitrate, I found that should allow you to make 6.75 grams of silver chloride. And I found that the 3 grams of calcium chloride should allow you to make 7.75 grams of silver chloride. Anybody else get those numbers? Give me a thumbs up if you got those two numbers. I can type a number in my calculator wrong. Happens all the time. Okay, awesome. So if like 8 of us got that, we're probably in good shape. Cool. So what do we have here? Well, the smaller number is going to be our theoretical yield. And the reactant that lets us make that's our limiting reactant. So silver nitrate is the limiting reactant. And the reactant that would have let us make more, that one is in excess. So now we can calculate a percent yield. So the percent yield equals the actual yield. So if you remember back in the problem, they said 5.50 grams. The precipitate was recovered. So that's my actual yield, 5.50 grams. We're going to divide that by the theoretical yield, 6.75 grams. And since it's a percent, we multiply by 100. The grams cancel out. So again, percents are unitless numbers. So 5.5 divided by 6.75 times 100. This individual has got an 81.5% yield. 81.5% yield. Woo! All right. All right. Cool. Hopefully you see that this isn't really more difficult than what we were doing last night. Hopefully you just see it's a little longer. It's a little longer. Now there is an extension that we can add on here, and that's how much of the excess reactant remains. We're going to do that here.